All right, good evening. It's February 22nd on a Friday evening, and we're going to be looking at, not this weekend, but next weekend, some key features that could produce a big storm in the first weekend of March. Not necessarily going to happen. A lot of pieces on the table. You could be nothing. You could be a big storm. But I just want to go through a couple of pieces, and particularly the differences between the GFS and the Euro, because they're really, really interesting. So the three key pieces of energy listed right here from the 12Z run of today's GFS are number one, this polar vortex lobe up in Canada, which really it's probably the least important of these three pieces because it's not a jump starter piece, but it becomes really important at the end, but I'm just listing it in this order because it's easier to go north to south in the situation. The second one is this huge piece of energy that the GFS has over in the plains, and this is really where it differs from the Euro. And the third is this region down here in the south across the Gulf of Mexico. GFS has this piece off the south to east coast, but as we'll go through it, the Euro is very, very different. And it's really going to be the differences in piece 2 and piece 3 that I want to go over to talk about why these models come up with such different solutions. Because if we go to the surface maps here, the GFS has this at day 8, this massive Great Lakes cutter, 979 millibar into Michigan. You see it's got a little bit of a secondary here from that energy we saw off the Carolina coast here. But for the most part, this is a true cutter. Very, very similar to what we've seen this winter. It's going to be stronger than most that we've seen, but it's still a very, very formidable solution. And in the European model did something completely different. It's got an ocean storm, a big, very powerful ocean storm here that's bombing. It's only 987 in this frame, but it bombs south of 980 millibars beyond this. But it's offshore. It's so far southeast sea. You got the GFS is way up in Michigan, and the Euro's got an ocean storm. So why? And the key differences begin after day 6. That's what we want to go to. So here first, I'm going to using the 12Z GFS runs, the GFS Euro, but I want to use the 12Z GFS run because 18Z was really, really similar, and it's just easier when you get the Euro and the GFS in the same hour to go back and forth. I just think it's less confusing, and they're both equally viable solutions. So at day 6, the GFS and the Euro are somewhat similar. I mean, 6 days out, you can see a lot of differences. There's huge differences over here, and there's also differences in the south, which we'll get to in a second. But the feature that they have similar, where I say somewhat similar, is this piece over here in the Pacific Northwest. The GFS has this piece entering Washington and Oregon here. Euro has it just offshore at day 6. So they both have this piece. Now what's key is the GFS is faster with it. So watch what happens over the next 30 hours, what the GFS does with this piece. So it starts taking it out of the Pacific Northwest here, rides it across into the Rockies, and then into the plains, and then boom, you've got an entire piece down here, a piece that ends up fueling this cutter. And if we go to the surface map over here on Tropical Tidbits, 174, you see that low starting to form at hour 174 out on the eastern side of this, and then that becomes the cutter bomb very, very quickly. If we run this forward, you can see why, because it really starts to tilt negative, and you got this piece of the polar vortex phasing in. But in any case, this piece, Pacific Northwest, comes out very, very potent energy out in the plains. What does the Euro do with it? The Euro does something completely different. If we run this forward now 30 hours again, the Euro keeps the main lobe hanging back out over the Pacific Northwest and only releases this little piece of energy, which is back over Wyoming and Montana, and very, very delayed. So again, GFS at hour 174, Euro at hour 174. They are completely different. So the reason why the GFS has this piece that ends up becoming this huge cutter bomb is because it releases all of this energy out of the Pacific Northwest, or yeah, pretty much all of it. I mean, the GFS, there's nothing really left behind. Euro just lets a little tiny piece break off, and it's barely, and there's barely a system here going forward. Now, what is interesting, though, as we go forward, is that the Euro, as this happens, develops a lot of energy in the Gulf of Mexico. And if we compare that to the GFS has nothing in the Gulf of Mexico. It has this piece that's actually out way in front. That's piece number 3. So as we transition to that, the GFS has this piece way out in front, and that actually originates back over here at the day 6.5 time frame. And notice the euro at that point, if you go back, had nothing. This is the euro at hour 156, GFS. GFS has this piece in the southeast coast. Euro has nothing down there. So GFS runs this out. GFS kind of used this as a secondary out here at hour 186, hanging off the coast, but the main show is back over the Midwest. The euro has nothing over there until it brings this piece out of Mexico and into the Gulf. And then it's got this big piece out in the Gulf. So the GFS that same hour, nothing going on down here. So if we look at the euro now, what does the euro have at this hour? And if we go forward, or hour 180, same time frame, I can go back one more. So this correlates to this exactly. The euro has this piece of energy is producing a storm in the Gulf, or at least it's trying to. It doesn't fully make it. It kind of goes on and off from here to through Florida and the southeast coast. But eventually, if we run this forward, that piece of energy jumps and becomes this coastal storm, which ends up just offshore. And the reason why it ends up just offshore, if we look at the European 500 millibar map here, you can see that Gulf energy, some of it's left behind. It jumps to the southeast piece, is that this plains piece that was very vigorous on the GFS is kind of weak. It does tilt negative, though, in this part of the trough, and then grabs some of the southern branch energy, and they phase together, and they create a nice little storm way out here. And so those are the two big differences. Number one, GFS releases a piece out of the Pac Northwest. The European does not. So here's that piece right here. And piece number two is that the GFS has a very weak system along the southern branch initially that it runs out ahead. The euro has the big piece that comes into the Gulf behind, which allows the low to jump on that southeastern part of the train. And then the third piece that we talked about in our initial, well, I'll bring it back up over here. I'll go back to piece number one, is this polar vortex lobe and the way it rolls around and how much energy phases in. And this is something that the models are very, very unsure about, but it can play a big role at the end in terms of how much cold air and how strong the storm can get, because there's a lot of energy up here. So if we look at the GFS in that aspect, well, you have a system where it phases in some of the energy. You can see right about day 8, right after this point, at hour 192, it's starting to phase in, and then it really gets aggressive and kind of dives in and engulfs the whole system. And this is why you get a very prolonged storm. If I run this forward now on the surface map of why this in parts of Ontario and Quebec and northern New England just get plastered with heavy snow. And if we can zoom in and show you the snow map that they have, and these are not accurate, but they give you an idea this far out, and you can see all the snow that falls up in this region over here. That would be a big storm for those areas. Let me get back to the GFS one. And here's the Storm Vista map. The folks there have very, very good winter maps, and bring it back. Here you see Cutter Bomb, and then it has the polar vortex lobe engulfs it. You end up with a big secondary storm that slams northern New England. But in any case, that's what happens when that piece gets aggressive. On the euro, we see that piece is actually much weaker, and this is one of the reasons why it misses off the coast. You see, there's detachment here. It's just kind of sitting up here, centered over northern Manitoba. It loops around a little bit. It starts to come down a little bit, but even so, even here, it's only really getting over towards Lake Superior. It's not digging down into the lower lakes of Ohio or Lake Erie or Pennsylvania. That's what you'd really want to see. Again, if we go back to the GFS here, look at the GFS. Look what the GFS does between day 7 right here and day 8.5. It just dives that piece of energy over the Great Lakes into, right over the middle of it. So if the euro did that, right, if the euro at that same time frame had this piece up here down over the lakes, well, this storm was forming off the coast, all of that phased together, and you would have had a monster if that would have happened, right? So you can easily say, well, what if the euro is right about this southern piece and the plains piece, but it's wrong about this, and you dive in and you get a huge storm up and down I-95. And you could say, well, what if the GFS is right about the initial system running ahead and being weak with no Gulf storm, and then the euro is right about nothing coming out? well, then you get nothing at all if you have that. So there's all sorts of combinations on these three things. I mean, obviously, yay or nay whether each piece is aggressive or not. You got 9 situations based on just on those 3 pieces right there, and they range from no storm at all to something astronomically huge if everything came together. There is a scenario, right, where the GFS is correct about this piece of energy right here in the plains exiting from this piece right here, where this all comes out. The GFS could be right about that, and the Euro could be right about this piece in the Gulf right here. And imagine if you had this storm in the Gulf, right? So you got a storm forming in the Gulf, and then this is to the north of it, and then they face together, and then this polar vortex dives in like that on top. I'm telling you, that would be a highly memorable solution. Not the most likely thing to happen, but it's one of the more interesting setups we've had all winter in a while. So it's yet to be seen if it produces, but those are the key pieces of energy I'm looking at, and that's why you have the GFS with a storm in the Great Lakes and the Euro with a storm offshore for now. I'm sure it will change tonight at OZ, so until then, we'll keep watching and see what happens. All right, that's it for now.